Welcome to Study Time, a televised home learning program produced by Rwanda Education Board.
Hello, dear students. Once again, welcome to this 30-minute session of TV learning programs. Once again, I'll be with the Senior 5 class, and we are still looking at unit number 8, which is about the esters, acid anhydrides, amides, and nitrites. As I said earlier, we are still moving on. We had finished esters. In the previous lesson, we talked about the soaps and detergents, and then that was how the soaps are, how the soaps act during the washing process or cleaning process. So we are now going to look at some of the exercises, some of the questions together, and then we see or we review. These questions will help us to review actually about the esters and what we have looked at all together. So without much ado, I invite you to go together. So as I will read the question, so you'll try to put down your answers, see whether you can still recall, and then compare what you have written down and what I'm going to write on the board. So question number 1, we go, make sure you have your pen ready and your notebook, so where you'll be writing, so that we don't leave you behind. So question number 1 goes, a compound A, C3H5, the compound A is C3H5 O2 chlorine. After boiling for half an hour with aqueous acid, yielded compound B. So the compound B is also given as C2H3O2 chlorine, and C. So when it was heated for half an hour with an aqueous acid, it was converted into B and C. So C is CH4O. Boiling A for half an hour with aqueous sodium hydroxide. So in the first case, it was heated with an aqueous acid. So in the second case, it was heated or boiled with sodium hydroxide. So it yielded compound D. And compound D is also given as C2H3O3 sodium. And then with compound C, which is not indicated. When B was boiled with aqueous sodium hydroxide, this compound B was boiled with aqueous sodium hydroxide, and the mixture acidified, it gave E. So E is also given as HOCH2COOH. Treatment of E, that is treatment of this E with sodium carbonate, resulted into a vigorous effervescence as E was converted into D. When this was treated with sodium carbonate, an effervescence which was vigorous, that means there was evolution of the gas. E was converted into D, which is this one. Deduce the structures of compounds A to D. So that is the question number 1. We need to put down the structures of compounds A to D. Fortunately, this compound A, its molecular structure is given. The molecular formula, I beg your pardon. The molecular formula is given. So we're just going to convert it into the structural formula. The structural formula is going to be showing, or the bonds that are linked, that are linking all those atoms together. So what we can do here, make sure you have your 3 carbon atoms, that is compound A. And then with compound A, you'll have the oxygen and then chlorine. It has 3 carbon atoms and 5 hydrogen atoms. So this is hydrogen, this is another hydrogen. We'll have an hydrogen with oxygen over there. This is HO, this is A, and then hydrogen. How many are they? So you need to go back and count them properly. The hydrogens are supposed to be 5. So this is 1, 2, 3, 4, 5. The oxygens are supposed to be 2. We have this one and this. We have chlorine, which is only that. So this is the structure of this compound A. Compound B, even the compound B is also given the structure. We are only converting the molecular formula into structural formula because the molecular formula of that compound is also given. So we just convert this. So this one has only 2 carbon atoms. So just look at first put the carbon atoms on the chain, and then it has still the chlorine. And you have the hydrogen atoms, which are supposed to be 3. So you have this one, and then you have, it is like this. 3 hydrogen atoms, 2 oxygen atoms, and then the chlorine atom. So this one, the structural formula of this is this one. The structural formula of this is this. Now, compound, we are supposed to write the structural formula of all the compounds A to D. So that is A, B, and then let's look at C. C is also given. So there is, C is given, so it is the structural formula. It has only 1 carbon atom with 4 hydrogen atoms. So with oxygen, so you'll have the hydrogen, and the hydrogen. How many are those? So you'll have, these are the 4 hydrogens. You need to count the hydrogens once again to confirm that they correspond. So this is the structural formula for part C. Please keep on checking whether you have the same structural formula because the compounds are given here. And we are not even going to reason. They are not asking us to reason out those conversions. What we are only asked is to deduce, and we deduce from what we are given. A, B, and D, where is converted into D. D is also given. It is over here with 2 carbon atoms. So D, 2 carbon atoms with, it has 3 oxygen atoms. So it has 3 oxygen atoms. So I would assume with 3 hydrogen atoms. This is the hydrogen. You have this and this. That is the structure of compound Da. D has the sodium instead of the hydrogen. So this must be the sodium with the hydrogen. That must be a sodium salt of a carboxylic acid containing an alcohol. So this is 2-hydroxy, and it has to be with sodium atom that is attached on this. You need to count the number of atoms. 2 carbon atoms, 1, 2, 3 hydrogen atoms. You have 1, 2, 3, and then you have the oxygen atoms, 1, 2, 3, and then the sodium atom. That is the structure of compound D. Then compound C, I think we have already indicated the compound C. Then E, A, B, C, D. So the E is given. So when this one was reacted with, we said when this reacts with sodium carbonate, this is a carboxylic acid. So carboxylic acids react with the sodium hydroxide, sodium carbonate to liberate the sodium salts of those carboxylic acid. So this one will be converted into this sodium salt of that carboxylic acid. B, so all these were, these are the compounds, and this was part A of the question. So go to part B of the same question. What product would be obtained? What product would be obtained? Under what conditions? When compound E and C react together. So where is E? So this is E over here. So we have compound E. They are reacting together. O, CH2, COOH, it is reacting with compound C. C is given. Remember, we have seen C as this. This is an alcohol. So we have CH3OH. So when you look at this, this is an alcohol. So this part of the alcohol, we have two functional groups. And remember, the functional groups determine the reactivity of the compound. So the reactivity of this will depend on the carboxylic acid. So this carboxylic acid reacts with the alcohol. Do you remember the conditions we had seen this reaction? What type of reaction is this? For example, because we had seen this reaction several times. I hope you still remember. This is esterification reaction. And then esterification reaction takes place in presence of the concentrated acid and heat. You remember we said about 100 degrees Celsius. And this will produce the ester that we are talking about. So this is HO, CH2, C. So you remember this hydrogen, the oxygen here and the hydrogen here will combine together. So we'll have COO, CH3 plus the water molecule. So this is the ester, the structure of the ester that is given. When compound E and C, this was E and this was C, they are reacting together. That is the product. The conditions are this. What is the name of this compound? So you remember what we saw, how we are naming these compounds of the esters. Let's move on to question number 2. A liquid A of formula, liquid A has formula C5H10 and O2. So whenever you look at the compound with 2 oxygen atoms, what comes into your mind? This compound is either an ester or a carboxylic acid. So just restrict yourself in that, among those homologous series. It is an ester or a carboxylic acid. Was reduced by lithium aluminum hydride to a mixture of alcohols A and B. So this compound was reduced into a mixture of alcohols B and C. So in presence of lithium aluminum hydride, this one reacts in presence of ether. 2 alcohols B and C was formed. So you need to get the information. Both alcohols reacted with iodine in alkaline solution to give a pale yellow crystalline solid D. So that takes you back to the reactions of alcohols, carbonyl compounds, with iodine in presence of sodium hydroxide, which we said that is iodoform reaction. So it takes you to the iodoform reaction. So you need to note that. So the iodoform reaction, what does this mean? It means that this compound, these alcohols, must be methyl alcohols. They either contain, the OH is attached to the methyl group of either a carbonyl compound or an alcohol. So this is the information that comes. Now, oxidation of C with a solution of sodium dichromate gives a product that reacted with iodine. Just take a look at that. Oxidation of C, so C was further oxidized. And if C was further oxidized, it means it is either a primary alcohol or it must be, or it is a secondary alcohol. Because if it is tertiary, they are not oxidized. Of dichromate gives a product that reacted with iodine still. So it was, the alcohol was oxidized to a carbonyl compound to form D once again. So identify and draw formula of A, B, C, and D. Give your reasoning. We have been trying to give the reasoning. Let's start with compound A. This liquid compound. So remember, it gave two compounds, two alcohols. So what is the structure of this compound? It has how many carbon atoms? They must be 5. C3, C, oh, there must be another oxygen because it is an ester. Remember, it was formed, it forms two alcohols. This is compound A. It forms two alcohols on reduction. So one of the alcohol is, now when this is reduced in presence of lithium aluminum hydride, one of the alcohols that are formed will be this. CH3, this is a secondary alcohol. This one, because the OH is attached to the carbon containing the methyl group, so when it is treated with sodium hydroxide in iodine, it will produce compound D. So which one is another alcohol? So this will be CH3, CH2, OH. So that is a primary alcohol that was further oxidized with sodium dichromate. So this is B and this is C. Those are the two alcohols. D, the iodide, or that crystalline solid compound. All these compounds, we call them either the methyl alcohols. They will produce iodoform, that we call it triiodoform, which is that pale yellow crystalline solid. So D will be CHI3. This is triiodoform, which is a yellow precipitate. This is a yellow precipitate or pale yellow orange precipitate crystalline solid. It is in solid form. So these are the compounds. We have that compound, that liquid A, which was converted into these two, and then one of them was oxidized by the dichromate to form the ketone, and that means it has to be either this. So give your reasoning. As I've been talking, I've just been giving the reasoning. From alcohol and an acid, the following, from which alcohol and an acid, this is another question. From which alcohol and an acid are the following esters made? Propyl propanoate. So we said this one is very simple, so you need to look at propyl propanoate. So this is the propanoate. Propyl propanoate. Sorry, to make a correction here. It have 3 carbon atoms. Propyl propanoate. This is propyl propanoate. And from which alcohols? This one comes from a carboxylic acid. This part, this is an alcohol. So it means it is coming from which alcohols and the acid. So the acid is this propanoic acid. And then we have propanol. So they are reacting together to produce that. We have another one, which is CH3. These are 2. So we may have CH3, CH3, and then you have H. Then you have, how many are they? These are 2. Then you have oxygen, CH3, CH3, 2, CH, OO, C, CH3. So we need to identify the alcohol from there. So this time, we can rewrite this structure in this form. If we rearrange it, it will be like this. CH3, CO, we'll have O, CH with CH3, CH3. To rearrange it properly to get the type of the alcohol so this will be a carboxylic acid and this will be an alcohol. So which one is there? This is a carboxylic acid with 2 carbon atoms. So this one will be ethanoic acid. And this one will be propan-2-ol. Propan-2-ol, that is the alcohol. Then the next compound we will have, that is this was part D. I think I made a mistake on copying. This was part D. I jumped part B. Part B is here. So we have CH3, CH2, CH2, CH2. They are repeated many times. Then we have COO, then CH3. So it is just the mere cross this one like this. So you have this as a carboxylic acid, and you have this alkyl group obtained from the alcohol. So this one will be, how many are they? 1, 2, 3, 4, 5. So this is pentanoic acid, and this one will be methanol. Those are the 2 alcohols obtained. So we have done, then we go to C. If we go to C, we have H like this, and then you have C2H5. This is ethyl, so that is ethanol. This one comes from ethanol, and this is methanoic acid. Those are the 2 acids together. E, you'll have C6H5CO. This one will be then with oxygen, CH with the CH3, 2. So this is the alcohol, and this is the carboxylic acid. So this part here, this is benzoic acid. This is a benzoic acid because this is a benzene ring. And then this one is 2,2-propanol or propan-2-ol. All those can be the questions. How would you carry out the following conversions? You have the ethanol to, that is a carboxylic acid. How do you convert these two? From ethanol, no, this is from an alcohol, which is propanol, and then move to this carboxylic acid. From, this is an alcohol again, which is a propan-2-ol. How do you move to this carboxylic acid? How do you move from ethanol, this is ethanol, to the ester as well? This is an ester that is formed. Two esters have the following formula, as we have seen. So let's try to do this one. Number 5, I will have to leave number 5 and some pad. So if we have two compounds, propanol to the ester that is formed. Allow me to remove this part. So you need to first prepare the carboxylic acid. So you are going to oxidize that alcohol, which is propanol. You oxidize this using any strong oxidizing agent in presence of acid, and heating or warming is enough. So this one will give you propanoic acid. This will change into the propanoic acid. Now the propanoic acid, so you have to make sure if you are preparing, because you start from this is the only alcohol that you have. So part of it will be oxidized. So you oxidize part to get the carboxylic acid. And then react the carboxylic acid that you have got with the alcohol, the original alcohol, in presence of the acid, and then heat. So you are going to get that carboxylic acid. So as we said, this one and this are removed as water, so you'll get CH3, CH2, COO, then CH2, CH2, CH3, and water. So that is even the way you first oxidize to get a carboxylic acid, and then you add it with an alcohol, the original alcohol, to obtain the final product. So let me leave you part B and C, and that part number 5 for you to attempt, and then see whether, because even number 5 is also talking about the esters. Thank you so much for being there, and I hope to see you in the next lesson. Have a good day and stay safe.